Hello, dear students. Today we are solving the ISI JRF MTA question paper for 2024, which will be useful for the students of 5, 6, 7, 8 everywhere. Okay, so now we have already solved 1 and 2. So today we are solving 3. N greater than equal to 1. Define f of n of x n square by n square plus x square. Prove that this converges uniformly on bounded intervals and doesn't converge uniformly in R. Okay, so here we have a pointwise limit we can apply over here. So just put it like this and solve it here. So limit n tends to infinity fn of x, limit n tends to infinity n square plus x square. So if x equal to 0, then fn of 0 is equal to 1. So limit n tends to infinity fn of 0 equal to 1. So if x not equal to 0, then for large value of n, fn of x, n square plus x square. So this will be 1 by 1 plus x square. If I just divide both sides, this by n square. So x square by n square tends to 0. If n tends to infinity, this follows that fn of x tends to 1 for all x. Okay. So the pointwise limit of fnx is constant function and fx equal to 1 for all x belongs to R. So now uniform convergence of the bounded intervals if we talk about. So the convergence of the bounded intervals in the minus m to plus m, consider that it's like the suprema. So here the suprema of this less than equal to m. So rewriting what we get here, n square plus x square is 1. So this will all be coming to x square, n square plus x square. Since this less than equal to m, so the suprema of less than equal to n square plus m square. Since the right hand side tends to 0 as n tends to infinity, so we can say that the here suprema of this less than equal to m fn of x minus 1 tends to 0. So thus fn tends to 1 is uniformly on every bounded interval in minus m to m. So now failure to uniform convergence, here we can say it like that the supremum value here fn of x 1 f suprema x belongs to R, x square n square plus x square. So in this case, for large values of x, what we can see, so fn of n is n square plus n square, so that is giving you half directly. Okay, so mod of fn half. So this is the lower bound and doesn't tend to 0 as n tends to infinity. So the uniform convergence fails in R. Okay, so the conclusion is fn converges uniformly only in minus m to m, and fn doesn't converge uniformly in R because the suprema doesn't tend to 0. Okay, so this is it for this question. In the next question video we'll solve question number